Okay, now that we've had the time of our lives, we have to get down to the nitty-gritty details of our nervous system, endocrine system, and the stress response. So when we were dancing, our nervous system was acting, and our endocrine system was acting because dancing releases endorphins, which makes us happy. Right? Are you all happy? Okay, I need to catch my breath. I danced harder than I thought I would. Okay. So, now that we're all settled down, could everyone raise their hand if they think that their physical health is important? Yes, all of us. Great. You're in the right place. Because, okay, if we all agree that our physical health is important, then it makes sense that we understand a bit about how our bodies actually work, right? Right? Yeah. Right. Great. Okay, so let's face it, without our health, we have nothing. It doesn't matter how knowledgeable we are, it doesn't matter how much money we have, it doesn't matter how famous we are, how many people love us. Without our physical health, that's it. Kaput, nothing. Okay, it all becomes meaningless, and what are we all doing it for, right? Because then you can't even enjoy the fruits of your labor. So it makes sense to pay respects to the thing that literally allows us to live, right? Yes. Right. Okay, so that, first of all, we usually take our health for granted until it's gone, right? When it's gone, then we start caring. Because we take it for granted the whole time. But why wait until that point? It just doesn't make any sense. Does it make sense? No, it doesn't. Okay? So that's why today we are going to become aware of and understand a bit about the two major systems that began our multicellular organism evolution, the nervous system and endocrine system. Okay? Okay. These two systems basically govern everything else in our body and make sure everything is working smoothly. But the difference between these systems is the nervous system communicates through electrical charge called neurons, whereas the endocrine system communicates through chemical messengers called hormones. So let's start with the nervous system. There are two main branches of the nervous system. The central nervous system, which is basically the brain, and the spinal cord, which both are bathed in cerebrospinal fluid. The central nervous system is basically our main information processor and integration center. So all of the information that our sensory nerves gather from our environment is fed back to our central nervous system, processed, and then it enacts some kind of response, a physiological response. So on the other hand, there's the peripheral nervous system, which is basically all the nerves and ganglia in our bodies that run through everywhere in our body, like electrical cables that transmit signals, okay? And feeds back signals to our central nervous system. Within the peripheral nervous system, there are two divisions. There's the motor and the sensory division. Okay, so there's the somatic nervous system, which is basically our voluntary skeletal movement. So when you guys were dancing, that was the somatic nervous system. And when you put your hand up, again, somatic nervous system. And when you walk and run and so on. However, there's also something called a somatic reflex arc, which is something that is like a sensory nerve or an afferent nerve, passes through whatever stimulus, like your skin, feeds back to your spine, and it completely bypasses your brain, and then your spine sends out a motor neuron to then have a muscular reaction. So that's when, like, you accidentally touch a hot stove, and then you instinctively remove your hand. So you didn't have to think, oh shit, it's hot, I should move my hand. You move your hand, okay? So that's the somatic division. So the next is the autonomic nervous system. Basically, this governs pretty much everything from your heart beating and breathing, your digestion working, your immune system working, your circulation, everything. You're not having to sit there and go, I should breathe right now, or else I'll die. No, your body knows, I need to breathe, okay? So very, very important autonomic nervous system. Within that, there are two branches. You've probably heard of them: sympathetic nervous system and the parasympathetic nervous system. So the sympathetic basically conserves your energy in order to utilize it in a fight or flight response, okay, which is your body's response to stress, versus the parasympathetic basically is in charge of your rest and digest state. So once your fight or flight response goes up, your parasympathetic puts you in the rest and digest state to further conserve the energy so that it doesn't get all wasted. Okay, so is that too fast? Am I speaking too fast? Okay, great. Okay. So, okay, I'll go into the parts of the brain because that's part of the central nervous system. It's very important. You must have heard of the brain, right? So the frontal lobe is for your cognitive higher functioning, so thinking, speaking, reasoning, problem solving. Then behind that is the parietal lobe, which is your sensory lobe, and it's in charge of your body orientation and your language. Then behind that is the occipital lobe, which is in charge of your vision. Then right below that, at the back, is the cerebellum, which is your coordination, your balance. And then at the bottom is the brainstem, which is connected to your spinal cord, and it's in charge of breathing and heart rate and temperature. Then on the side is the temporal lobe, which is to do with your auditory ability, but within that is the limbic system, which is comprised of your hypothalamus, thalamus, amygdala, hippocampus, which is kind of like your emotional processing center for memories and behavior. And people also call the limbic system the reptilian brain, or like the second brain, because it's like your reflexive reactions to things, and it's also your emotions. So obviously a lot of us, sometimes we don't think logically. So we think with our emotional response first. And so that's why people call it the second brain. Okay, so sorry, back to the sympathetic nervous system. So basically, the sympathetic nervous system is your stress response. So when you encounter a stressful stimuli, or you perceive something to be stressful, it might not even be a stressful thing, but you have perceived it that way, then the body stimulates and mobilizes your energy and pumps adrenaline into your bloodstream. So that would increase your heart rate and dilate your lungs, and it lowers your gastrointestinal motility and secretion. It loosens your bladder, it increases metabolism, and you have more sweat and less saliva. So in order for it to actually do this and to mobilize all the energy so that your body can then respond, like if there's a dangerous stimuli there, your body thinks you're being threatened, your safety is being threatened, then you have to have a burst of energy in order to get away or fight or flight, right? In order for it to do this, it needs to take energy from other areas of your body. Okay, so that's why it has to shut down your digestion, because your digestion uses energy all the time, and it shuts down your immune system, which is always adaptive immunity. It always is working, which requires ATP energy, and for example, your reproductive cycle also. So all those things shut down, which in the moment, as an acute response, is fine in order for you to get away from the threat. However, if the sympathetic nervous system is activated for a long period of time when it's not supposed to be, then all of the organs that need energy and that usually use energy have no energy, okay? Because your body is too busy being stressed. So then your digestion, your immune system, your reproduction, it all becomes dysfunctional because there's no adequate energy going to those places. Okay, then that's when your body just goes out of whack, and then you go into disease. So overactive sympathetic would cause anxiety, panic attacks, nervousness, insomnia, palpitations, poor digestion, high blood pressure, high cholesterol, and so on. So yeah, here's a diagram of the fight or flight response. Basically, your hearing shuts off. You get tunnel vision, you breathe faster, your heart starts to beat faster, so you've got a pounding heart, and your digestion slows. You get tense, and your bladder relaxes, which is why you feel like you need to go to the bathroom when you are afraid. Okay, so on the other hand, as I said, parasympathetic nervous system is what happens when your body goes into a relaxed state, okay? So if your sympathetic nervous system is just leaking energy, you're just constantly producing adrenaline, and then all your organs are not getting energy, then your parasympathetic has to usually kick in, okay? But usually when people have chronic stress, that sensitivity of the systems is, it loses sensitivity basically. So your sympathetic is abnormally stimulated, so then your parasympathetic nervous system tries to overcompensate because there's too much stress hormones going on. Because it's trying to overcompensate, it tires itself out. The parasympathetic becomes worn down from constant suppression, and then eventually the ability for you to relax just degenerates. So you just, physically you can't even relax. It's harder and harder for your body to go back in your rest and digest state. So then your sympathetic has no regulator. Your sympathetic nervous activity is just through the roof because your parasympathetic activity is so dysfunctional. By the way, in parasympathetic, your heart rate is lowered and your digestion and secretion increases, your bladder becomes stronger and your metabolism lowers, your pupils constrict. So basically, you calm down. So what I want to do is I want you guys to watch two different videos, and I want you to notice how you feel and the difference of how you feel between both of them, okay? Okay. Okay. Okay, got that? Who's crying? I'm crying too. So, how did you guys feel watching the second video versus the first video? Yeah, so which one's the sympathetic? The first one, yeah. And the second is the parasympathetic. Yes, and this horse is actually calming down the patient's sympathetic nervous system as well, and brings them back into the parasympathetic, where they can actually relax enough to feel their emotions and feel their heart. And it also brought you guys into a parasympathetic state as well, because we were all like jittery from dancing, and then now we're all calm, we feel relaxed, our heart rate slows, our breathing deepens, we are feeling tears, feeling, how do you feel? Peace, joy, gratitude, all those things, yes. Okay. So, okay. I just want to touch on the vagus nerve. This is the 10th cranial nerve. It is the main parasympathetic nerve in the body, but this nerve can actually get, the connection of this nerve can actually be shut off when you have chronic stress, and then because that nerve has shut off, the parasympathetic nervous system function actually becomes impaired. Okay. So, okay. So in a fight or flight response, right, we perceive a stressful event, so our amygdala, the part in our brain that is responsible for emotional processing and reactions, fast reactions, sends a distress signal to the hypothalamus to then activate the sympathetic nervous system to pump adrenaline into the bloodstream for a boost of energy, right? You know that. So this is kind of, this connection of the hypothalamus and the pituitary gland and the adrenal gland is called the HPA axis. So the HPA axis is in charge of the sympathetic and the parasympathetic nervous system for the hormones to travel rapidly between these organs. So then after the fight or flight, your parasympathetic usually would kick on, right? However, if your brain continues to perceive that there's a threat or that there's danger or some kind of stress, then your parasympathetic does not get stimulated, and instead your hypothalamus secretes corticotropin-releasing hormone, which then secretes adrenocorticotropic hormone from the pituitary gland, which then goes to the adrenal glands to secrete cortisol, which is the main stress hormone. Okay, so cortisol has a negative feedback loop with the hypothalamus. So usually once cortisol is secreted, then it sends a signal back to the hypothalamus telling it to shut off production of corticotropin-releasing hormone, so it doesn't continue producing cortisol. However, if there's a continued stress response, then that negative feedback loop can eventually start to degenerate, and then once you actually secrete cortisol, then because there's no negative feedback loop, your hypothalamus continues to secrete corticotropin-releasing hormone, which then continues to secrete cortisol. So that's when you're stuck in a loop, okay, and that's when things like autoimmune disease would arise.
Imagine you're getting ready to race. The stress you feel makes your brain signal the adrenal gland to produce epinephrine, or adrenaline. Adrenaline increases your heart rate. As a result, more oxygen gets to your muscles. That makes your body ready to react. In a longer-term response to stress, the glands secrete cortisol. Cortisol promotes the release of energy, making you ready to race.
Yes, so as you know, stress actually affects all areas of our health, and you know why? Because stress physiologically creates inflammation, which is the body's response to purge toxins out of the surface, okay? But as a result, inflammation, when it's not acute response, when it's not an acute response of inflammation, instead it's chronic inflammation, that is actually the major cause of all disease, and people don't actually usually know that. And so when you have chronic inflammation, that means your body can no longer heal itself, like your cells are not mobilizing to even heal itself, repair, or regenerate its own cells. So then what happens when you can't repair your cells? Then your cells die or they become diseased, and your body starts to attack itself. You can even bring this on not even physically, but mentally or emotionally. If you are fighting against yourself mentally or emotionally, right? It's like you are trying to be in denial and you're trying to repress your feelings and you're trying to disown yourself and you're constantly fighting, then your cells are also constantly fighting. When your cells fight themselves, that's the literal definition of autoimmune disease. That's when your cells can no longer differentiate your own cells versus invading pathogenic cells. So you just start to break down physically. And so, yeah, stress affects your digestive system. So people would get ulcerative colitis or irritable bowel syndrome when they have chronic stress, or they'd get high blood pressure or chronic pain in their joints like arthritis. And even like hormonal problems, menstrual problems, infertility, chronic fatigue, thyroid disorder, diabetes, hyperglycemia, depression, anxiety, insomnia, you name it, okay? So you'll find that stress, chronic stress, and emotional stress that you've brought on yourself is the actual main cause of a lot of these things because it causes inflammation. Okay, so I know I repeated a lot of stuff about that, but I did want to reinforce things. Did you all get that? Yeah, great. Okay, so I want to move on and I want to talk about what actually makes up a nerve, okay? Because your nervous system is made up of nerves, and your nerves are made up of nerve cells, which are neurons. So this is the anatomy of a neuron, briefly, okay? So you've got the cell body, which basically integrates and processes information and protects the cell. On the end are called dendrites, which they are like little branches that receive signals from other neurons, okay? And obviously within is the nucleus, the brain of the cell. Then this long part is the axon, which transmits the signal to another neuron, but the axon is surrounded by a myelin sheath, which is made up of lipids and proteins, which basically protects the axon from degradation and also ensures that there's like a rapid transmission going on. And then at the end is the axon terminals, which house vesicles that have neurotransmitters. So these axon terminals transmit a signal to another nerve to then transmit a signal to another nerve, and so on and so forth. But the way for these neurotransmitters in the axon terminals to be secreted into the synapse, you need to have an action potential. Okay, so sorry, here's like an actual diagram of that. So here are the vesicles in the axon terminals. They hold the neurotransmitters. When an action potential fires to fire a certain cell, the neurotransmitters are released into the synaptic cleft, which is the space between two neurons. Then they bind to the receptors on the dendrite of another cell. Okay? Make sense? Cool. Okay, I'm going to quickly go over membrane and action potential. Okay, I'm going to like simplify it though. Okay, so in order for us to have thoughts or actions or senses, our neurons have to fire, okay? When they're not firing, that neuron is at resting potential. So that means the inside of the cell is negatively charged and the outside of the cell is positively charged. The resting potential is minus 70 millivolts. So for an action potential to fire, the cell charge has to go to 0, okay? So yeah, when the neuron is at rest, basically the way it maintains being at rest is through a sodium-potassium pump in which 3 sodium ions are being transported out of the cell and 2 potassium ions are being transported into the cell. And because there are more cells leaving, more ions leaving the cell than entering the cell, that makes sure the inside of the cell is negatively charged, okay? So when neurotransmitters bind to the receptors of another cell or another neuron, they have a depolarizing effect on the neuron, so it starts moving towards 0 millivolts. So it has to basically reach this minus 55 millivolts, and that's the threshold. So when the threshold is reached, the sodium channels open, sodium ions can go into the cell. That makes the cell positively charged. With the influx of positive neurons, the electrical signal or the action potential fires. That's when your neurotransmitter is being released, and the signal is going down the axon, and it's going to the next neuron, and so on and so forth, okay? Once that fires and the action potential reaches its peak, then the sodium channels close and potassium channels open, so the potassium flows out of the cell, and it causes the neuron to repolarize, so your action potential falls, okay? Then it falls to below the resting potential, so it goes into hyperpolarization, which is like a refractory period. Refractory period means that the same neuron can't fire immediately again, okay? It has to repolarize. So here's a quick video. So these are the sodium ions repolarizing the cell. Sorry, these are the sodium ions repolarizing the cell. So that's an axon terminal with the vesicles holding the neurotransmitters in them, sending them into the synaptic cleft where they are being taken in through ion channels. This is not exactly accurate, but this is like just a visual representation. I wanted to show you how cool it looks, okay? Because it's pretty cool. Like, what is this? It's pretty insane when you actually watch it. It's like, really, that's happening like at all times with less than milliseconds. It's happening with everything you do, with you breathing, blinking. You know, every single thing you do is happening because of your nerves firing, okay? And we don't even know it. It's crazy. That's why we're learning about it. Okay, so you know about synaptic connections. So basically, there's this thing called neuroplasticity, which is the ability of the brain to form and reorganize synaptic connections. And it usually is in response to learning. So frequently used synapses. So when those nerves are firing and then it goes into that refractory period, if you keep thinking, if you keep thinking the same thought, or you keep doing the same action, and that synaptic connection continues to fire in the same way, then that refractory period gets shorter, so that those neurons actually fire quicker the more you do it. So that's why synaptic connections, the more you use them, the stronger they get, the faster they fire. And then the synaptic connections that are barely used, they start to, eliminate themselves, okay? They get weaker, then they eliminate themselves. So when you have a strong synaptic connection, that's usually because you have a habit, some kind of pattern that you do every day, you think every day, you feel every day, or some kind of behavior that you do every day. So there's established thought patterns. So the more you do them, the longer you do them, it becomes harder and harder to break it. It becomes harder to de-strengthen those synaptic connections. But it's not impossible, okay? So people say that, I can't learn anything new, I'm too old. Or I can't change, he can't change, he's too old, I can't change his habits. Or I'm too far gone, I can't change my habits. It's not true. Like, just because when you're young, your brain easily creates new synaptic connections because your brain is still developing, doesn't mean that it's all over for you once you get older, okay? So, pretty much, each time we feel the same emotion, okay, we choose the same thought, we choose the same emotion, we trigger the same neurons, and then we trigger the same hormones to then release, and we trigger how we feel, okay? It creates how we feel. Hormones create how we physically feel in our body, then that may create our actions, which then creates our state of being, right? But what happens if you choose a different thought that chooses a different synaptic connection to fire, and then that triggers another hormone to release or not release? And then that triggers you feeling differently in your body because that hormone did or did not release. And then you have a different feeling, so you act differently, and you treat others differently, and you see the world differently, and then your state of being eventually changes. So it's possible by conscious decision, okay? Your consciousness is actually what governs your brain. Your consciousness, I guess, on the physical level, your consciousness is your brain, but if you are your thoughts, on a physical level, if you are your thoughts, and your thoughts are just neurons firing, and then your neurons trigger the hormones and triggers how you feel, triggers your physical health, triggers your state of being, then technically that means you can control everything, okay? It means you can control your state of being. You can decide how you feel, and you can decide if you are healthy or not, okay? It's a matter of choice, and it's a matter of consciousness, and it's a matter of awareness, and making that conscious choice every morning when you wake up, choosing to, no, I'm not going to react to this asshole. Okay, like I always do, I'm going to react. My synapse is so strong. I could just really easily, call them a bad name, but I won't. I'm going to use the techniques that Hong and Mike taught me, and I'm not going to react, and I'm going to keep my dignity. Okay, I'm going to choose another path. I'm going to choose the road less traveled. My synapses won't like it because they'll have to make more effort, but that's the way it goes. So you make new synaptic connections and you keep making that different choice. You keep feeling that different way. You keep acting in a better way. Then eventually those synaptic connections get stronger. And then once they actually become stronger and then your previous pattern gets, weaker, then that's not your habit anymore. Now you're in your state of being, and your first response to being triggered is not, I'm going to kick him in the balls. It's, I love you, I accept you, I understand, I'm not going to curse you because I love your soul for who you are. Okay, and this is not you. Okay, I understand that this is not you, and I'm not going to take it personally. I'm not going to let it affect how I feel. Okay, I'm not going to let this asshole trigger me. That's power. Okay, you feel powerful, right? It's powerful because you're taking responsibility for how you feel. You're taking responsibility for your health, how you feel, your life, and you're taking responsibility for your reality, okay? You can't blame anyone then. You can't go, oh, he made me feel this way, so I had to act that way. He was asking for it. Like, it's easy to think like that. And, that's probably, your synapses are super strong there, but, it's actually real power when you can own every single thing in your life. You can own your physical health, and no one can take that power away from you, okay? That is your God-given right. It is what gives you self-respect. It is what gives you dignity. It is what gives you self-worth. And it is what helps you cultivate self-love, okay? And no one can take those things away from you because then that becomes your state of being, okay? Does that make sense? Yes. Okay, so that's kind of covered the nervous system, which, super simplified, by the way. It's super, more complex than that. But now it's time to go into the endocrine system. Okay, so the endocrine system is a network of glands and organs that produce, regulate, and transport hormones. You can kind of think of your endocrine system as like a huge manufacturing transport company. It's like the Amazon of your body, and your hormones are like all the workers, and they basically control everything from your metabolism, your energy, your reproduction, your growth and development, your sleep, your mood, everything. So when an endocrine hormone is released from a gland because of a neuron signals it to release from that gland, it travels through the bloodstream to a target organ where it then binds to receptors to enact a physiological response. So that could be release another hormone, or make cells grow faster, or absorb sugar from the blood, otherwise you get hypoglycemia, withhold water from the kidney so you don't drown like where you sit. So there are 4 types of endocrine glands. Quickly, there's the endocrine glands, which secrete hormones directly into the bloodstream. Then there's the exocrine glands, which secretes hormones to the surface of the duct, like a duct on the skin, like sweat or saliva. Then you've got paracrine glands, which produce hormones which act on the cell next to it, which is like your ovaries. And the autocrine glands produce hormones which act on the cell secreting it, so like blood clotting, right? Prostaglandins in blood clotting. So, okay, the main endocrine organs. You've got the hypothalamus, the pituitary gland, the pineal gland, the thyroid gland, the thymus, the pancreas, the adrenal glands, and the testes and ovaries. Okay, so the nervous system and endocrine system are pretty much connected. They work together, but they are connected through the hypothalamus because the hypothalamus contains cells that can send and receive both endocrine and nervous signals. So the difference is that the nervous system, like an electrical signal, is immediate because it's like an electrical charge that it has to hit a threshold and then fall. So it's immediate, but it's fleeting, and it also works more specifically and localized, versus the endocrine system is slower and longer lasting and body-wide because the hormones have to be secreted directly into the bloodstream, which takes a longer time to actually travel through the whole body to the organ, but it gets there and it has a longer response. So the endocrine system is pretty much regulated by this thing called negative and positive feedback. I kind of mentioned negative feedback earlier. It's like when you turn a tap on and then you turn it off, okay, instead of just leaving the tap on. So pretty much, this is when a product of a reaction leads to a decrease in that reaction. So when a gland secretes a hormone, the release of that hormone will trigger the gland to stop releasing that hormone, okay? It regulates it. Or if a gland secretes a hormone, then the release of that hormone will trigger another hormone to release, which inhibits that hormone. Got it? Such as like your temperature, your core body temperature, your thermoregulation, so you don't get too cold internally or too hot. Blood sugar regulation, because such as your pancreas releases glucagon, which causes your blood sugar to increase. Then, when your blood sugar increases, that triggers your pancreas to release insulin, which then causes your blood glucose to drop. And then when your blood glucose drops, that triggers your pancreas to release more glucagon, and so on. It's a never-ending story. That's what I mean by a negative feedback loop. It basically regulates everything. You don't need to just know that that exists, okay? So on the other hand, there's a positive feedback loop, which is used less. It's when the product of a reaction leads to an increase in that reaction. So the gland secretes the hormones, then that triggers the gland to secrete more of that hormone. An example is in childbirth. So when your uterine walls stretch in childbirth, it triggers oxytocin, the endorphin, which the release of oxytocin further causes your uterine walls to contract, okay? And then that produces more oxytocin and so on. So that makes sense, right? Yeah. Okay, so now, are you with me? Yeah. Okay, I'm gonna go through the main endocrine organs, okay? So, the hypothalamus is number one. It's the chief regulator of the endocrine system, and I like to think of it as the CEO. It's the chief executive officer, okay? It tells everyone what to do. And it basically controls most of the hormone release, so including body temperature, hunger, thirst, behavior, energy, sleep, and your sleep-wake cycle. So it gathers information sensed by the brain, such as your temperature or light exposure and how you feel, and sends it to the pituitary gland, okay? So this information influences the hormones that the pituitary makes and releases. Basically, the hypothalamus tells the pituitary gland what to do. It doesn't do like much work on its own, but it tells the pituitary gland what to do, and the pituitary gland does all the heavy lifting, okay? And the hypothalamus and pituitary gland are like right next to each other, like you can see there. And they're connected by this kind of bridge called the hypophyseal blood portal system. And that system basically ensures rapid transport of hormones. So the main hormones transported by that system is the gonadotropin releasing hormone, which triggers your reproductive hormones, corticotropin releasing hormone, which, as you remember, is your precursor to stress, growth hormone, and thyrotropin releasing hormone, which is your thyroid. So the hypothalamus forms many signaling axes with other glands, such as the HPA for stress, the HPG, which is hypothalamus pituitary gonads for reproduction, and HPT, which is hypothalamus pituitary thyroid, which governs your metabolism. Okay, so now the pituitary gland is his right-hand man. Okay, it's the COO, the Chief Operations Officer, otherwise known as the master gland. Again, does all the heavy lifting. When the hypothalamus sends a signal, he goes, aye, aye, Captain. So there are 3 lobes of the pituitary, the anterior, posterior, and intermediate. The anterior, which is like the front part, controls most of the hormone responses, including stress, by secreting adrenocorticotropic hormone, growth, reproduction by releasing follicle-stimulating hormone and luteinizing hormone, which are essential in your menstrual cycle, and proliferation of your eggs that then get fertilized when you get pregnant. And then metabolism rate, so thyroid-stimulating hormone, and then lactation by secreting prolactin. Please don't fall asleep, guys. I don't know how to make this more interesting. Okay. Bear with me. So, okay, posterior, which is the back of the pituitary gland, controls your uterine contraction, so oxytocin, and blood pressure regulation and kidney function. And the intermediate lobe, which is the middle part, produces melanocyte-stimulating hormone, which is important in skin protection and pigmentation. Okay, I'm going to jump right into ovaries and the menstrual cycle. Oh, I forgot to do the testes. Okay, I'm just going to... So sorry, oh my God. Okay, I'm going to do the ovaries and the menstrual cycle. Okay, so... Because it related to me, so I forgot. Okay. Okay, so the female gonads are found on either side of the uterus, as you know. They produce and store eggs or ovum and hormones that control the reproductive system. So basically, once puberty starts, your hypothalamus secretes gonadotropin-releasing hormone, which kind of primes your reproductive glands, and it secretes it in an increased pulsatile fashion until you basically have your period. And then that causes the production of sex hormones like estrogen, progesterone, and testosterone. So a menstrual cycle, I'm mentioning this because not many people actually know, like girls. So a menstrual cycle starts on the first day of your period and ends at the start of your next period, okay? So an entire menstrual cycle may last between 24 to 40 days, but it can vary. So the entire duration of a menstrual cycle is divided into 4 phases. You've got the menstrual phase, which is day 1 to 5, usually, which is when you're having your period, okay, you're bleeding. Then from day 1 to 13 is your follicular phase, which is when your eggs are starting to become proliferated to then become mature to then become an egg. So then about 2 weeks after your actual period, you have day 14, which is your ovulation, which is when that mature egg is now released into the fallopian tube to await fertilization. okay? Then when it is not fertilized, then you're in your luteal phase from day 15 to 28, basically to your next period, which is when your uterine layer or corpus luteum starts to break down. Okay, so this is important because stress really affects fertility for women, okay? So just a few ways that it does is that corticotropin releasing hormone, which is the precursor stress hormone, inhibits the gonadotropin releasing hormone secretion, which in turn inhibits follicle stimulating hormone and luteinizing hormone production. So it can result in anovulation, so no period, and therefore like infertility on a long period. Cortisol, which is the main stress hormone, also suppresses progesterone. And because progesterone is the regulator of estrogen, that means you need, that means your estrogen becomes unchecked, and then having too much estrogen can cause endometrial dysfunction. So, yeah, stress really affects fertility, okay? Okay, so moving on from that, we're going into the adrenal glands. These are the small bean-like glands located above the kidneys. They secrete the stress hormones cortisol and adrenaline and aldosterone. But they also produce androgens that convert into sex hormones, so estrogen and testosterone. So in the stress response, they release epinephrine and norepinephrine, which is responsible for the body's rapid response during stress, as you know, as I talked about to death. Okay, so the thyroid gland. Do you guys know, okay, who knows about the thyroid gland? A lot of people don't actually know about the thyroid gland, but it's super underrated, okay? It's a really important gland. It's a butterfly-shaped gland in the neck. It stimulates the metabolic rate, basal metabolic rate, and growth and development, and it secretes 4 major hormones, so thyroxine, which is T4, triiodothyronine, which is T3, and thyroid-stimulating hormone and thyrotropin-releasing hormone. You don't need to remember the names. Okay, constant release of these hormones regulates your body temperature, energy levels, metabolism, brain development, cardiovascular and bone development, liver function, and pregnancy. So the body actually needs iodine, an essential trace mineral, in order to make thyroid hormones. So a lot of people actually have like an iodine deficiency, and that can cause thyroid disease. And there are 2 main thyroid diseases, which are autoimmune disease. One is hypothyroidism, which is when your body doesn't make enough thyroid hormone, and so it may cause like fatigue, cold intolerance, weight gain, hair loss, menstrual cycle changes, and fatigue. Oh, I said that. And then hyperthyroidism is when your body produces too much thyroid hormone, or when the negative feedback loop associated in the thyroid synthesis becomes degenerated by stress. Then you get hyperthyroidism, which means your thyroid hormones are going unchecked. Okay. So yes, your hypothalamus secretes thyrotropin-releasing hormone to the thyroid gland. The thyroid gland then starts to make thyroid-stimulating hormone. Then the thyroid-stimulating hormone starts to secrete T3 and T4. And it has a negative feedback mechanism on the brain to stop producing thyrotropin-releasing hormone. So as I said, if that negative feedback loop is not working properly, then you get way too much thyroid hormone production. Okay, so again, the thymus gland. This is another really underrated gland. You guys need to know about the thyroid gland. Wake up. Don't fall asleep. Okay, it's not a useless gland, guys. People think it's useless because it's like the biggest in childhood, and then it shrinks in adulthood, but it actually controls and coordinates your entire immune system because immature white blood cells travel to the thymus gland to mature into T cells, which are like in charge of your adaptive immune response. They attack invading cells, invading pathogens, okay? So your immune system, pretty much during maturation, the T cells undergo this thing called VDJ recombination, Gesundheit, And then it enables T cell receptors for your immune system. However, it also enables autoreactive T cells, which basically start to recognize its own cell as an invading cell, which is not good. So if they escape the central tolerance, then it becomes harmful. And then the body destroys its own cells, and then that becomes an autoimmune disease. However, there's these things called medullary thymic epithelial cells, or MTECs, that then deal with these clones through positive and negative selection. Positive selection is when the T cells that only moderately bind to its own antigens survive, and negative selection is when the T cells that bind with a really high affinity go apoptosis, which is programmed cell death. So then after the T cells mature in the thymus, they enter the bloodstream and travel to the lymphatic organs to aid the immune response. So the thymus is both an endocrine and a lymphatic organ. Okay? You with me? Yes. Okay, okay, pancreas. We're almost there at the end. So the pancreas is both an endocrine and digestive organ. The exocrine role is to produce enzymes to help digest food. But the endocrine role is that it produces insulin, which lowers the blood sugar, and glucagon, which raises your blood sugar. So in people with type 1 diabetes, the pancreas doesn't produce enough insulin due to the immune system attacking its own cells that make insulin. So then you become insulin dependent. And then in type 2 diabetes, the body's cells don't respond normally to insulin. So then glucose can't enter the cells as easily, so it builds up in the blood, and that makes insulin resistance. So when a lot of blood sugar enters the bloodstream, the pancreas pumps out more insulin to try and get the blood sugar into the cells. However, over time, the cells stop responding to all that insulin, so the pancreas just keeps making more insulin to try to make the cells respond. But eventually, the pancreas can't keep up and the blood sugar keeps rising. So you get hypoglycemia or diabetes type 2. So yes, lack of exercise can also cause your muscle cells to lose their sensitivity to insulin. So guys, you need to exercise. Okay, last but not least, guys, the pineal gland. I've saved the best for last. Everyone loves the pineal gland. Okay, yeah, it's a tiny pinecoat-shaped gland in the center of the brain. It's so small, but it does so many things. So the main function is the production of melatonin, the sleep hormone, which regulates the circadian rhythms, which is the sleep-wake cycle, okay? So damage to circadian rhythms causes pretty much all like sleep problems like insomnia, daytime drowsiness, decreased alertness, poor decision-making and memory, trouble falling asleep, so on, and like even depression and anxiety as a result of not sleeping. So when your retinal photoreceptors in your eyes register that it's dark, then your brain upregulates melatonin and it's released into the bloodstream and the cerebrospinal fluid to make you feel sleepy. However, in Eastern medicine, and it goes back to like Pharaonic Egypt and the Age of Enlightenment with the philosophers such as René Descartes, they thought the pineal gland was the seat of the soul or the third eye for its central location in the brain and the secretion of DMT, the spirit molecule, which kind of causes like psychedelic visions or astral visions. So, unfortunately, this organ has the highest calcification rate, and physically it could be because of fluoride levels in the water, electromagnetic radiation from technology, obviously chronic stress, aging, poor nutrition, but in Eastern philosophy, a calcified pineal gland usually is associated with like a dysfunctioning crown chakra, which governs your pineal gland, and it's associated with your higher self, your spirit, and your intuition, okay? How much time do we have? Oh shit, oh my God. Oh my God, okay, I'll just quickly say one thing. Okay, guys, sorry. Sleep is your best healer. You know why? Because when you're sleeping, your body undergoes cellular restoration and protein synthesis and muscle repair, okay? So when you're sleeping, your memory function is being improved because you're converting short-term memories into long-term memories, as well as erasing unneeded information that might otherwise clutter your nervous system, so that it increases your learning ability, your memory, problem-solving skills, creativity, etc. It also helps your emotional stability because your limbic system is resting and regenerating, and it also affects your weight because it controls your hunger hormones and the hormone that allows you to feel full. And it also helps your immune system because during sleep, your body makes cytokines which fight infection. And this is cool, guys, okay? It detoxifies your brain because when you're asleep, your cerebrospinal fluid detoxifies the brain by collecting all the waste and metabolites and toxins, including a protein called beta amyloid, which may contribute to Alzheimer's, and flushes them into the blood for detox. So your brain is literally getting washed while you're sleeping, okay? And that's called the glymphatic system. I just wanted to mention that, okay? And yeah, each endocrine gland is associated with a chakra. So crown chakra is the pineal gland, the third eye is the pituitary gland, and the throat is the thyroid gland. Your heart chakra is the thymus gland, solar plexus chakra is the pancreas, sacral chakra is the adrenal glands, and the root chakra are your reproductive glands. You'll get this slide afterwards, so don't worry. So I'm going to end it here. I'm going to end it. Okay, so if there's, wait, hold on. If there's one or two things that you get away from this, don't worry if you didn't get it. So if there's one or two things you take away, is that one, we obviously have miraculous bodily systems. Like, you can't look at that and not be impressed. You can't look at that and go, oh yeah, I could do that. I don't know. You can't look at that and go, that's not cool. So, and this is only the tip of the iceberg. Like, this is like a very brief overview. So obviously just imagine this and times it by 1,000. So the fact that that's going on in our systems constantly 24/7, like as we speak, without us even knowing about it or even caring about it, is pretty amazing. Wouldn't you agree? Yeah, it is. So take that away. So think about the next time you are telling yourself negative thoughts or you're feeding yourself terrible toxins and you're poisoning your body, then just think, you know, I'm poisoning this miraculous creation, you know, and when you're disrespecting your body, you're disrespecting yourself, which means you're disrespecting God or whatever you perceive him to be. So please be aware of that. The second thing you should take away is that you are the actual creator of your reality, which my dad and my mom have said, but physically it's true, as I said, because yeah, if your thoughts are just nerves firing, then, and you can choose if your synaptic connections are getting stronger or weaker, then you can control the release of your hormones, which you can control how you feel, which you can control your physical body, your health, and you can control your actions and your state of being. So it's all up to you, okay? It's all your responsibility. So claim that power, yes? Thank you. I'm going to pass it to Mum.